Welcome to the channel Maths Graduates. Today we'll show that cardinality of set n cross n is equal to cardinality of set n. Okay, that means Cartesian product of two natural number sets equals to the cardinality of set of natural number. Okay, so let's prove. For that, what we'll do, we'll define a mapping f from this Cartesian product of natural number sets n cross n to set of natural number. Okay, and this mapping is defined as f of x y, this equals 2 raised to power x into 3 raised to power y. Okay, now our claim is this mapping f is 1 1. Okay, so let's show that. So let's assume f of x1 y1 equals f of x2 y2. Okay, then from the definition of mapping f, it will be 2 raised to power x1 into 3 raised to power y1, this equals 2 raised to power x2 into 3 raised to power y2. Okay, from here we can also write this as 2 raised to power x1 over 2 raised to power x2, this equals 3 raised to power y2 over 3 raised to power y1. Okay, now in left hand side we have 2 raised to power x1 minus x2, and in right hand side we'll have 3 raised to power y2 minus y1. Okay, now for any value of x1 and x2, in left hand side we'll have 2 raised to power something, and in right hand side we'll have 3 raised to power something, and we know that GCD of 2 and 3 is 1. That means these two values cannot be equal. It will be equal only when this equals 1. Okay, so when 2 raised to power x1 minus x2 is 1, we get what? We get x1 minus x2, this equals 0. We know that if any number has power 0, then value of that expression becomes 1. So when 2 raised to power x1 minus x2 is 1, that means x1 minus x2 is 0. So from here we get x1 equals x2. Okay, and now when 3 raised to power y2 minus y1 is 1, so from here we get, this is only possible when 3 raised to power y2 minus y1, we can write this 1 as 3 raised to power 0. So from here we get y2 minus y1 equals 0. So y2 becomes equals to 1. Okay, so now we can say that this x1 comma y1 is equals to x2 comma y2. Okay, why so? Because x1 equals to x2 and y1 equals to y2. Okay, now from this relation, when we had taken images are same, then we see that input value this input value is also same. Okay, and we know that when images are same and input values are also same, then the function becomes 1 1. Okay, so f is 1 1. Okay, and we also know that if any mapping from domain to codomain, if that mapping is 1 1, then cardinality of domain, which is n cross n here, it is less than equals to cardinality of codomain. Okay, suppose this relation is 1. Okay, now let's define another mapping G from n to n cross n. Okay, and this mapping G is defined as G of x equals x comma 1. Okay, now again I am going to make a claim, and the claim is that this mapping G is 1 1. So let's see what happens when images are same for two different x1 x2. So G of x1 equals G of x2. So from the definition of mapping, it will be x1 comma 1 equals x2 comma 1. Okay, now these two order pairs are same. It will be only same when this x1 becomes x2 equals to x2. Okay. So here we can see that whenever images are same, then input value is also same. So we can say that G is 1 1, and again from the definition what will happen, that cardinality of domain will be less than equals to cardinality of codomain, which is n cross n here. Okay. Suppose this is relation number 2. Now from relation 1, cardinality of n cross n is less than equal to cardinality of n, and from relation 2, cardinality of n is less than equals to cardinality of n cross n. So from these two relations we can conclude that cardinality of n cross n will be equals to cardinality of n. Okay. And this is what we had to prove. This completes the proof. Okay. From here we can also say that since both the sets have same cardinality, so we can also say that this set n cross n is countable. Okay. Now we can also generalize this concept that this any set n cross n is also similar to n cross n, and this also similar to. Okay. And for any countable number of Cartesian products, okay, for any, here we have countable number of copies, this is also similar to n, that means it is countable. So this set is also countable. Okay, let me write it here, that if we have n cross n and if we have countable number of copies, then it is countable. Okay. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSR NET, GATE and other MSc entrance examination can buy our real analysis handwritten notes for a very reasonable price for only ₹80. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.